Hello, everyone, and welcome to our newest webinar introducing the National Laboratory Gasification Consortium. My name is Crystal Stabell, and I'm a Senior Program Coordinator at the United States Energy Association. USEA is a nonprofit, apolitical, non-lobbying organization founded in 1924. USEA's mission has two pillars of equal importance. First, USEA serves as a resource by convening energy stakeholders to share policy, scientific, and technological information to foster the advancement of the entire energy sector. Internationally, USEA promotes energy development by expanding access to safe, affordable, sustainable, and environmentally acceptable energy in partnership with the US government. USEA's Consensus Program, launched in 2008, is a cooperative program with the US Department of Energy's Office of Fossil Energy and Carbon Management to promote consensus on the need for carbon capture, utilization, and storage, and other clean fossil energy technologies. With that, I would like to transfer this over to our wonderful lineup of speakers, starting first with Dr. Nathan Weiland.
All right, thank you, Crystal. We appreciate USEA's help with setting up this webinar for you. Again, welcome to the National Laboratory Gasification Consortium, our introductory webinar here. Share my screen briefly. So you're joining a consortium of 4 different national labs here, our NETL, Idaho National Laboratory, Oak Ridge, and NREL. We will dive into some logistics here quickly. So as Crystal mentioned, this webinar will be recorded. The presentation slides will be available at the USEA website within 24 hours here, as well as that recording. In addition, we'd love to get your feedback, your comments using the chat feature here. We do have a pretty full agenda, so we may not have time to answer those questions today, but we will certainly review your feedback. In our agenda, we do want to start out with kind of brief introduction of ourselves, the NLGC in particular, and the background that led up to this consortium. We do have a brief kind of online participant poll just to engage folks on what we're trying to put forth here on the gasification front, and then talk through our organization and how we're addressing the challenges of the gasification community as a result. We do have reviews of the individual technical tasks as part of the NLGC, and a summary of the overall effort, and then at the very end, we'd like to introduce the industry data survey, because we are looking for your feedback so that we can ensure that we are doing work that is most relevant to you and impactful to you as gasification industry participants. So with that, I'm going to move on to the brief introductions. Again, I am Nathan Weiland. I'm a senior fellow at the National Energy Technology Laboratory and our hydrogen portfolio lead. We'll just kind of go across the rows here, and I'll turn it over to Ed to introduce himself.
Hi, my name's Ed Wolfram. I'm a chemical engineer by training. I'm a principal researcher and group manager at NREL in Golden, Colorado. I am also serving as the principal investigator of the BETO-funded Feedstock Conversion Interface Consortium.
Hey everybody, I'm Mike Talmadge. I'm also from the National Renewable Energy Laboratory, and I primarily work on process modeling and techno-economic analysis. And as it relates to the NLGC, I'm leading the modeling and analysis task in this work.
Hello, everybody. My name is Jordan Klinger, Senior Research Engineer at Idaho National Laboratory. A lot of my work focuses on materials pre-processing and granular flow mechanics within the context of the NLGC here. I'm leading the work with respect to processing of coal and waste resources for gasification.
Hello, everybody. I'm Jim Parks. I'm Section Head for Energy and Industrial Processes at Oak Ridge National Laboratory. In this consortium, I'll be leading the feedstock variability sensing and control task, as well as our industrial engagement activities. So thank you for attending.
Hi, everyone. My name is Mehrdad Shano. I'm a team supervisor for computational multi-phase flow science team at National Energy Technology Laboratory. The team is focused on developing modeling tools, in particular CFD modeling tools dealing with reacting multi-phase flows. Thank you.
All right. Thanks, everybody. So I'm going to dive in real quickly to just a brief snapshot on the NLGC as a whole, just some kind of boilerplate information. This is a consortium run out of the Office of Fossil Energy, specifically the Advanced Energy Systems program that's directed by Bob Schreckengas. Within that program, the sub-program that's running that is the gasification sub-program. Jay Wo Kim is the program manager there, and Jonathan Lexi is the NETL technology manager. Again, I'm leading the consortium, and we've just met all of the co-principal investigators here. Just briefly, the period of performance, this is planned as a 4-year activity. Our budget for the first year is a little over $5 million for this year. Okay. With that, I'll turn it over to Ed, who's going to run through a little bit on our the background of the NLGC, and take it away.
Great. Thanks, Nate. So the NLGC background, I think we're all, probably everybody on this call is very familiar with the overall concept of gasification. We can take solid feedstocks, make syngas, and then do low-cost production of fuels and chemicals. The Office of Fossil Energy's gasification program has been working gasification for a long time and has recently funded individual work at all of the 4 labs that are represented here, and they were combined into a single project starting earlier this year. The Research Innovation Center, Rick is leading that. That's Nate's role. They are the experts in this area and have a very good understanding of the overall field. The benefit of working together is that everybody's doing what they do best. Really good communication across and between the laboratories. And we can get more done. Our goal is to get more done than any of the individual labs can do alone. And again, this is building on previous work within the Office of Fossil Energy, but also work that's been funded by the DOE Bioenergy Technologies Office, or BETO, including the Feedstock Conversion Interface Consortium, FCIC, ChemCat Bio, and CCPC. I'll make one last point is my colleagues may be tired of hearing me say that, but labs don't work together. People at national laboratories work together. So many of us have worked together in the past. And so this is a natural collaboration to focus our efforts moving forward. And so what are the expertise at the individual folks at the national laboratories? Idaho National Lab are represented today by Jordan. They have the Biomass Feedstock National User Facility, Buffalo. They are the experts in pre-processing materials, turn resources into conversion-ready feedstocks. The Oak Ridge team has done a lot of work in resource assessment, billion-ton study, and some sensing work. The NETL folks are famous probably for the MFIX computational dynamic fluid CFD system, and they are both the software and the validation part of it. NREL works largely in the conversion area, looking at feedstock and product chemistries and generating data to validate models. And we are all taking our own individual areas and contributing to it. I'd also mention the modeling work. Each of the laboratories has a process modeling and a techno-economic analysis modeling team. That work is being led, as we said, by Mike Talmadge at NREL. This started out, we've been working independently before 2024. We had a kickoff meeting over a year ago to start thinking about how we're going to organize this. Got the final work plan in very, very early this year. Kicked it off in late April. And here we are today to share our plans with the broader community. So we're going to do a quick online poll. This is going to be very fast, 3.5 minutes max. It's completely anonymous. We just want to see who's on the call. And we think the folks on the call might be interested in seeing who else is on the call. We're going to ask a few questions. There'll be a couple of ways to participate. We'll get that on the next slide. But this will just be really quick, just to warm up, just to see who's just to see who's here, so we can know that going forward. So the next slide.
I'm pulling up the
Yep.
link. Will be in the chat, available for everyone.
Oh, that's right. Yeah, so we can click on that. You can click on the chat if you want to do the poll on the computer that you're watching. If you want to do it on the phone, there will be a QR code shortly. I'm of a vintage where I like to do things on the computer, so we will or you can type in old school and just type in menti.com and use that code, which is the same as the link in the chat. So we will give everybody just a couple of seconds to decide how they want to best do this. And we'll run through these questions. Why don't we get started right
Let's
now?
begin.
So we're looking for, you can just click on it, which or which best defines your organization. Are you mostly involved in feedstocks? Are you mostly doing the reactor design operation? Are you a vendor in the general area? University, government regulatory? Again, this is completely anonymous. We are not looking for details here. And if one of these categories isn't exactly perfect, that's completely fine. So let's talk a little bit about feedstocks, right? We need solid feedstocks. And some of these are petroleum-based and some of these are maybe bio-based. You can, on this question, you can pick up to 3 different responses. Again, we're just looking for rough numbers. I see a lot of people interested in Woody and MSW. That makes a ton of sense. Oh, we got 55 people taking this. Look at us go. This is really interesting. So we in the NLGC don't have a favorite, but it's nice to know that some of you do. And Woody Biomass MSW looks like they're in the lead. Somebody's got to put a tiebreaker in there. So excellent.
Let's move on to the next question.
Okay, super. Reactor types. Obviously, most people on the call are very familiar that the different types of gas fires work slightly differently. So you can pick up to 4. We're and looks like fluidized bed is heading out to an early lead. And in train flow, okay. And everybody seems to be getting the hang of this pretty quickly. Look at us go.
All right. Shall we move on to the next question?
Sure. And the reaction type. So this is more about the chemistry. So not so much the reactor design per se, but the chemistry. Are we looking at pyrolysis, autothermal pyrolysis? And what's your process gas, primary process gas? And again, you can choose multiple responses just to get us a feel for what people are mostly interested in. And it does look like gasification is, by definition, pretty much the primary interest, which is about what we would have expected.
Let's move on to the next question then.
Okay. So can you give us an estimate over the next 5 years, whether your organizations will be installing or operating gasifiers and what ranges? And this is only get to pick one. So, we see a lot of the smaller scales coming in and a lot of the largest ones. That's an interesting dichotomy. And if your organization is set up to like focus on feedstocks, and you won't be doing this, no obligation to complete the question. So I think we've hit everybody who's going to answer.
Let's move on. And this is the final
Okay.
question.
So we have an idea of what we think the key challenges are, and we'll be hearing more about those later in the seminar, but please let us know what you guys think the issues that you're most challenged with. You can pick up to 6, and 6 out of 8, so that should be good enough. We've got this is almost evenly split between the feeders and the gasifiers at a very high level. Well, I think we are probably at the limit there. So thank you very much. It looks like we've got folks mostly interested in gasifiers who are going to be working at less than 5 tons per day, and the feedstock variability and reactor operability are both key issues. Thank you very much for that. I hope that was interesting to everybody. It was certainly very helpful to us, so we know how to focus it. And again, as Nate mentioned, we do have a industry survey, which we'll share the link at the end. You can fill it out and provide more information if you'd like. And we'll talk about that more at the end of it. So with no further ado, I'll hand it back to Nate.
Yeah, thank you, Ed. Yeah, really good to hear all of the challenges everyone's put forth here seem to be pretty much in line with the specific areas where we are working. So very encouraging for us to hear. There have been a lot of workshops and requests for information that have come out over the last 2 to 3, 4 years even in the gasification space. So there's a couple of links on the side here, the gasification workshop summary. If you click on this later, that'll pull up the report from that workshop, as well as the workshop at the bottom here. The others are not public, but kind of pulling all the information together from those various workshops and the RFIs, there's a number of kind of cross-cutting challenges that have come to the surface that the NLGC is going to be working on. One of those is analysis tools, again, wanting to look at assessing the waste resource availability and the cost, environmental impact from utilizing those waste resources. And basically, what are some tools to enable the industry to come up with some economic decisions on where to site gasifier projects and what resources to use, et cetera. In addition, there's a lot of trade-off assessments that we'll need to make, both technical and economic, on pre-processing gasifier selection, syngas cleanup. Are you using what is your feedstock type? Is it pelletized? Is it ground? What type of gasifier do you use? What type of syngas cleanup do you use, depending on the contaminants included there? In addition, we do have a need for, or there was expressed a need for, some cost-effective and in situ feedstock variability measurements. If you have in particular a waste resource coming into your gasifier, if you know how variable that is, as it's being fed to the gasifier, you can do a better job optimizing your gasifier's operation. That variability, there is also a need to kind of assess that on broader terms. What's the full scope of variability of a particular waste resource? MSW, waste agricultural residues, forestry residues, etc. And can that fit into the operational envelope of my gasification plant? In addition, what are some of the specific pre-processing requirements for various types of feedstocks, and in particular relevant to the contaminants? What are the alkali metals present? How much tar is going to be produced? Is there chlorine, halogens, etc.? Other unusual contaminants? How do we assess that in advance? And finally, linked to that as well is looking at the reaction kinetics for all of these alternative feedstocks and even blended feedstocks, so that we can do a better job of gasifier plant design, scale up of those gasifiers, and even on the operational side, look at digital twinning, or, for instance, if I can measure the variability of my feedstock going into the gasifier, how can I adjust in real time based on these reaction kinetics, the operation of my gasifier? So that sort of forms the basis for the work that we've are endeavoring to undertake here. So our main goal, enabling some economic utilization of a broader spectrum of alternative and blended feedstocks to help ensure fuel resiliency in gasification systems here. The three, say, main objectives in doing that through the NLGC. We do want to engage industry to do this collaboratively to help tackle those feedstock challenges, utilizing some of the capabilities that we have here. We do want to help you expand the gasification feedstock base that's available to you through waste resources, mixtures of those resources with coal, biomass, or other products. We're a little bit more agnostic to the final end use of that syngas, whether that's for energy, fuels, chemicals, or hydrogen, but do want to expand the feedstock base for you. And to help do that, we would like to provide data, information, and some tools that will help you do that in essence. So kind of looking overall at the space, again, on the left-hand side, various feedstocks, and we can add to this. You guys mentioned a number of other feedstocks that you have interest in. Waste plastics came up quite a bit. Different types of biomass, of course. Pet coke was included, and there are others as well. But looking overall in kind of a holistic perspective at the broad spectrum of feedstocks available, what are the transport mechanisms that sort of feeds into the systems analysis piece, the costs associated with that, and the feedstock pre-processing that you might utilize for any one of those feedstocks. Once that's done, we're kind of looking at the on-site storage and feed of those feedstocks into the gasifier using that feedstock quality sensing piece. And then once it's in the gasifier, what are the kinetics associated with gas pyrolysis and gasification of those alternative and or blended feedstocks? Again, not very specific to your end use, but looking mostly at the kind of the gasifier and upstream, essentially. So the way we are organized, we're kind of broken down into 5 tasks. Task 1 is led by myself. It's more just the coordination piece. Again, not very technically interesting, so I'm not going to cover that in a lot of detail, but each speaker here or task lead will speak about their tasks in turn as we go through the presentation today. So task 2, kind of the overall systems analysis task, looking at supply chain modeling and analysis, led by Mike at NREL. And task 3, we're looking at upstream of the feedstock quality and the pre-processing of those various feedstocks, led by Jordan at INL. Under task 4, we're looking at sensing of various feedstocks in a real-time and in situ sense for variability so that you can affect control of your gasifier. That piece is led by Jim Parks at Oak Ridge. And finally, task 5 is looking at the kinetics database and a machine learning tool for gasification and pyrolysis kinetics, led by Mehrdad out of NETL. So where does this fit in the overall scheme of gasification? Again, we'll be hearing about task 3, the upstream feedstock quality and pre-processing piece, highlighted here. Task 4, again, more looking at the kind of on-site and in situ sensing of feedstock variability as it's going into the gasifier. Task 5, looking more at gasification-specific kinetics, although I'll note that we're not trying to be specific to a particular gasifier type. We are trying to develop kinetics expressions that could be utilized in any type of gasification, essentially. And finally, we have task 2, which is sort of tying everything all together there. With that, I'll note just briefly an org chart on how everything is set up here. Of course, everything is run out of the FECM gasification program run by Jay and Jonathan, and they're our primary conduit or link to other DOE offices, BITO, HFTO, etc. Task 1 is, again, kind of the FWP coordination. So we're coordinating on all of the technical tasks listed at the bottom here. And then also there is a stakeholder group which helps inform that FWP coordination task led by Jim Parks. And this is sort of the introduction to help form that stakeholder group. That's what the webinar is intended for today. So I'm going to dive a little bit. I just got a couple slides on the coordination piece. Again, not the interesting part of the NLGC, so I'm not going to spend a lot of time on it. But our goal here really is just coordinating the labs to help meet the FECM's gasification program goals, helping develop an impactful scope, facilitate communications, in particular with stakeholders, and then manage all of the data that's coming out of the consortium. So again, just wanted to highlight a few things relevant to coordination reporting, things that you can expect out of us. We will be putting together written annual reports at the end of each year, so roughly March 31st. They'll probably be coming out publicly shortly thereafter each year. So something tangible you can read in the progress of the consortium as we go forward. In addition, some stakeholder management and communications. Again, Jim's leading that, but we do have, again, just to highlight some items, this is our introductory webinar today. We are planning to do some additional presentations and virtual meetings. I'm going to discuss that a little bit in the next slide. I'll say we also have to manage the data that's generated here, as well as data that potentially may be supplied by yourselves, the gasification community. So we have we've done some data needs and assessment coordination, doing that on an annual basis. We have a data management plan we'll be putting forth in about a month. And then we'll be talking about, in the next slide, a data repository for public use here. So on our stakeholder interactions, we would like to meet with this group on a perhaps even broader on a roughly biannual basis. We'd like to do in-person meetings. Those would roughly coordinate or align with the FECM and NETL project review meetings. Those typically happen anywhere from the April to June timeframe. It's usually held in Pittsburgh. I believe the one for 2026 should be held at the convention center here in June of 2026. So I'll need to look for specifics on that at a later point as that gets closer. In addition, we'd like to do, roughly every kind of in between those meetings, a virtual workshop. So just as timing would have it, that would roughly land in January this coming year. So please be on the lookout for that as well. Relevant to data management, NETL operates EDX, which is our internal data repository. It is a very secure system and is used for a lot of other efforts across the lab and across DOE. It is vetted by the DOE office chief information officer and is a very secure site for data sharing and warehousing. We will be putting together a private site just for internal use very shortly, and that'll be followed by a public EDX site where we can share data sets, etc., with that we are generating with the broader public. Date says June 26, but we will probably get that out sooner than June. Finally, I should note that that's in part, there's a lot of data already available through INL's Bioenergy feedstock library. We'll be adding new feedstock blends to that library, and so that data as analyzed and developed under task 3 will be added to the library and linked to through EDX as well. So if you're familiar with that tool, we'll be incorporating and adding to that as we go. So with that, that's kind of the overall scope on just the management and coordination piece. At this point, I'm going to turn it over to Mike Talmadge, who's going to talk through technical task number 2, which is a supply chain modeling and analysis. Mike?
All right, thanks a lot, Nate. Okay, yeah, so let's go through a high view summary of the supply chain modeling and analysis task. Our primary goals in this effort are one, to model and evaluate cost and emissions minimization. We have previously largely been focused on hydrogen production with a recent shift to syngas, but I noticed we've still got hydrogen there. Syngas is our focus. The second goal here is to identify promising locations for technology deployment. We'll get into like kind of, the integration of resources and their locations and the full supply chain analysis that we intend to build upon that. But the starting point is really where the resources are located. And third major goal is to publish useful tools for the industry and hopefully kind of promote commercialization and deployment of these gasification technologies. And we intend to accomplish these goals largely through, as Nate said earlier, kind of bringing everything together in this analysis task. So again, starting with resource data sets for mixed MSW and waste MSW, herbaceous materials, and coal, to really get into the details of the sorting and pre-processing strategies based on what the resources are and what they include as far as contaminants, and what the various gasification technologies downstream will require as specifications for those contaminant species and things like that. We'll certainly integrate process modeling and techno-economic analysis for a number of gasification technologies and focus on syngas cleanup steps that are required for different downstream utilization options of the syngas. We've got market considerations included in here for the options for downstream utilization of the syngas. So thinking about, what are potential off-takers and products that would ultimately be derived from the syngas. Last couple of things are to really kind of bring all this together in a waste to syngas and even product supply chain analysis framework, and then to publish a couple of tools. So we'd really like to publish tools that help the community on the front of TEA, facility siting, and also process design. You can go to the next one there, Nate. So here's a quick intro to our team. So we've got 5 subtask leads here. So myself, Eric Lewis from NETL, Bob Wallace from NETL, Tammy Lynn from Idaho National Lab, and Gary Grimm from NREL will be leading our primary subtasks in this and modeling and analysis work. And then we've got representation from all the labs, of course, in our team. Okay, so I think this is the only one with any kind of automation, but essentially there's our supply chain scope. And then we're building the subtasks around this supply chain concept. You can start clicking through there, Nate. So starting with feedstocks, markets, and facility siting. So these guys have a lot of space to cover. So they're responsible for identifying the resources and where they are located and quantities, in addition to identifying opportunities for product utilization and use of the syngas. Okay, and then there's a huge piece of this supply chain puzzle in getting from resources to suitable feedstocks for gasifiers. And this is where the Idaho National Lab led team will focus on options for contaminant mitigation and really trying to optimize cost, emissions, and the whole product quality of the materials fed to the gasifier. All right, and then following the feedstock sorting and pre-processing, of course, we enter the gasification process modeling effort and corresponding TEA and emissions analysis. And then we've got 3 sort of cross-cutting subtasks that are really sort of covering this whole space, starting with data coordination. So as Nate's mentioned, the NLGC level effort to sort of coordinate data gaps and fill them through industry engagement and of course research. Okay, and then this middle guy is really where we're trying to bring it all together. So putting the pieces of the resources and the modeling aspects for pre-processing and gasification, bringing those into a full resource to end use supply chain analysis framework. So that's a big goal of ours. And then I mentioned some of these public facing tools. So the design handbook is one of them. So we would like to, in similar form to what NETL has published historically around gasification design handbooks, we'd like to integrate some elements of these alternative feedstocks and how to provide some design guidance there. Okay, so we're going to dig in a little bit to these individual subtasks, starting with feedstocks, markets, and facility siting. I mentioned that these guys have a large space to cover. So they're first tasked with integrating data sets for waste biomass. So the billion-ton study was mentioned. That's our primary data source for waste materials, including both biomass and mixed MSW. And then we're bringing coal into the mix here as well, which is a good thing, because as many of us know, like, scale is an important element in economic analysis. So bringing coal into the mix really kind of gives us an opportunity to really explore the impacts of mixing feedstocks to gain scale. One of the other big elements of this subtask is really providing GIS-based analysis capabilities. So both on the resources, infrastructure, market side of things, understanding and having GIS-based data and capabilities allows us to get into some of that facility siting analysis work, which is really cool. We want to connect the resource data here directly with the sorting and pre-processing models that Idaho National Lab is leading development of. So this is really an important connection point between the qualities of the resources and what's ultimately needed at the back end of the sorting and pre-processing technologies to feed the gasifiers. And then lastly, in this task, we want to publish an economic analysis and facility siting tool to sort of help and engage the industry stakeholders. Go ahead, Nate. Okay, resource sorting and pre-processing. So basically what Idaho National Lab is doing here is applying previously developed models and certainly further developing those into a robust modeling framework that considers things like resource availability, resource quality, and then of course those quality specifications for the gasifier and what we expect feeds would need to look like in terms of being able to reliably feed and operate gasification-based systems. And then Idaho has basically developed this menu, if you will, of pre-processing technology options for sorting, size reduction, moisture management, densification, and of course contaminant removal is an important aspect as well. And then what we're doing with the menu of processing options is sort of optimizing that configuration and then modeling costs and emissions from those optimized configurations. So we've got a little example over there of a probability plot around cost, but essentially we're doing the same for both costs and emissions profiles. All right, go ahead, Nate. Okay, on the process modeling front, of course, here what we're doing is applying our Aspen Plus based process models here with a coupled TEA and LCA framework to basically do the math around yields, conversion costs, and emissions. And then, of course, integrating the outputs and the modeling bases from the sorting and pre-processing subtask and directly linking that with the process models for gasification. Yeah, we feel like flexible models are really important here, especially because now we're really focusing on syngas. So, understanding the variables that impact potential utilization of the syngas for power, fuels, chemicals, and the like. We recognize that certainly syngas qualities will be different for those different downstream options. Let's see, we certainly intend to incorporate data and learnings from the NLG research tasks. So certainly the sorting and pre-processing task and major feedback loop from the kinetics work that Mayor Dodd will talk about shortly. And then out of this subtask, we're also providing the conversion basis for that full supply chain analysis framework. Okay, next one, Nate. Yeah, so this is where we're kind of bringing everything together in this integrated analysis framework, subtask. So the intent here is to really explore some of these important questions around cost and emissions minimization, optimization, and the areas that we're kind of honing in on are, initially at least, are plant scale versus like feedstock collection radius and the resulting transportation costs and emissions, right? So while we fully recognize that scale is important for costs, you know, the whole trade-off is having to transport a bunch of materials to a centralized gasifier. Trade-offs between co-location with resources versus syngas consumer. So we'd like to, you know, explore those aspects through scenario analysis, and then identifying specific locations that are of high interest for potential commercialization. And then let's see, yeah, things like blending feedstock. So this is an area where we're really going to look, I think, to industry guidance as far as like setting initial constraints and limits as we work to, you know, sort of mix various feedstocks and put them in, you know, a single gasifier or different multi-gasifier strategies and things like that. And then lastly, looking at you know, limitations and opportunities of different gasifier technologies. That survey was really cool because it kind of gave us you know, guidance on our prioritization of gasifier technology. So initially, we're sort of focusing on fluidized bed and entrained flow gasifiers with you know, the hope that we will address additional technologies down the road in the consortium. All right. We've got a couple of goals as far as public-facing tools. The first one is, as I mentioned, kind of focused on the supply chain techno-economic analysis, emissions estimates, and facility siting. So the figure shown here is an example of some initial facility siting work that NREL did in collaboration with NETL prior to the NLGC. And so what we're doing here is sort of identifying hotspots for potential plant locations based on the resources available in that neck of the woods, and then also importantly, in this case, hydrogen offtake opportunities that exist. So, you know, big yellow spot shows up in the Gulf Coast because, you know, we've got a ton of hydrogen consumers there. Okay, Nate, let's jump to the next one. Okay, and then the other public-facing tool that we'd like to disseminate is focused on alternative feedstocks and incorporating alternative feedstock design considerations into this NETL gasification design handbook. And then I believe I have just a couple more slides. The last is on the data coordination and industry engagement effort. So you can see we've just kind of listed here the areas in which we'd really like to talk with industry experts and get ideas about how to incorporate or address some of these considerations in our analysis. Nate, go ahead and click that one more time. I want to highlight these specific areas because I think early on, these are going to be really important for us as we start to develop TEA and LCA scenarios. So guidance on mixing feedstock types. So, you know, how much X do we think can be mixed with feedstock Y, for example? So guidance on those, and we'd be really interested in talking to folks following this webinar about specifics in these areas. And then the other is specific syngas cleanup needs, and really kind of driven by reliability concerns. What are the specific syngas cleanup needs based on feed contaminants? So just wanted to highlight a couple of areas we'd really like industry feedback. All right, last slide, Nate. Okay, so I am handing this over. We're transitioning now from modeling and analysis, and we're going to focus on upstream feedstock quality and pre-processing, and Jordan is going to lead that discussion. So take it away, Jordan.
Hey, thanks, Mike. Appreciate that. So in the work that in the consortium regarding the upstream feedstock quality and pre-processing, the major goal, of course, is to look at conversion of coal and these waste carbon resources, MSW and waste biomass, et cetera, ultimately into a feedstock that is conversion ready, meeting the different quality attributes and certainly economic optimization targets that are needed in order to make an impact and be reliable. As a result of this, the main objectives that are kind of bulleted out here, just a few of them, looking at identifying the optimal pre-processing pathways with respect to the feedstock, as well as potentially variable feedstock quality targets in order to convert them into these conversion-ready feedstocks, and looking at producing validation data with respect to the processing methods, looking at documenting mass and energy balances, for example, through different pre-processing stages and different configurations of those stages, as well as the trade-offs between increasing the pre-processing intensity and how that ultimately impacts the feedstock quality. And then, of course, with the interface with the actual conversion work, how that propagates through conversion, impacting the kinetics of those conversion and the quality of those conversions. The cartoon on the bottom right-hand side here, just for a quick overview of what we're talking about here, shows a few potential optimization targets, looking at a particle size or a format, the inorganics and heating value, and overall what we're trying to do is increase the operational effectiveness, which is kind of a combined metric of the reliability and throughput of this material with the overall conversion performance over that variability space for different resources. So of course, like all the work in this consortium, I have the pleasure of speaking on behalf of a great many researchers who are participating in this work. A lot of them from INL, but of course, participation from each of the national laboratories, NREL, Oak Ridge, and NETL as well. Looking at the high-level activities that are going to be performed in the next year and, of course, the coming years through the consortium in this work, of course, collecting and characterizing the feedstocks is first and foremost. From those feedstocks identified through the work that Mike was just talking about and the resource assessment, producing a range of feedstock for all of the experiments that kind of unify all of the results and the outcomes from this consortium, and taking that data, whether it's the characterization of the feedstocks, the metadata and provenance of those feedstocks, as well as archival of the physical samples through the library and the EDX platforms that Nate had introduced. Ultimately, the major experimental effort in this work, of course, is the physical transformation of those materials through the pre-processing, sortation, and formatting of these materials, carrying that through decontamination of the feedstocks. So, for example, whether it's looking at dechlorination of a waste plastic stream or looking at heavy metals abatement, potentially looking at transforming those properties to be suitable for a conversion feedstock. Of course, everything that we do in this pre-processing task is weighted and evaluated through conversion. So there's a heavy emphasis on evaluating the quality of the feedstock and looking at the interface between the feedstock quality and the conversion performance, and ultimately having an introspective look at what we're doing in the pre-processing and looking at improving those methods with diagnostic tools to help maintain the pre-processing operations. A lot of this work will take place at Idaho National Laboratory within the Buffnuff, which is the Biomass Feedstock National User Facility. There's a few kind of photographs shown here on the right, but really what this is it's a capability and a national asset to look at de-risking the scale up and pre-processing and the configuration of pre-processing in order to enable the transformation of feedstocks for the bioeconomy. And really what we're doing here is looking to understand the fundamentals of the materials processing, which will enable ultimate mobilization of these feedstocks for use in conversion processes. So whether it's looking at a very small gram or kilogram scale, this houses opportunities up to the multi-ton an hour processing scale that's reconfigurable, ultimately a reconfigurable test bed for the public and private sectors. Next slide, please. Thanks. So this kind of shows an overview of one potential configuration of the facility, but beyond the CF conveyors, there's a few of the capabilities highlighted here. For example, looking at the size reduction of materials. So whether it's looking at different modes of size reduction, impact milling, shear-based milling, etc., a number of different unit operations there. conditioning of the materials, looking at densification, sorting and separations, whether it's through physical attributes like density or the aerodynamic properties of the material through air classification, or through chemical signatures, whether it be IR-based sortation or vision-based systems. This slide shows an overview of the initial feedstock processing that'll take place within this first year of the consortium that we've been talking about, focused on southern yellow pine, coal, and MSW that Mike had introduced. For these whole resources, we'll look at several different methods of processing, ultimately with the goal of evaluating different formats and preparations of the material. So a coarse shred and a fine shred here, looking at formulating feedstock blends. So whether it's a mixture of southern yellow pine and MSW, or perhaps coal and MSW, or waste plastics and the clean whitewood of yellow pine, looking at taking those materials, going through different size reduction steps and formulating those materials and potentially densifying those materials through pelletization, for example, into different blends that can be evaluated for gasification. Of course, the southern yellow pine and MSW themselves are inherently somewhat complex mixtures of material. And to better understand the inherent kinetics of these complex mixtures, whether it be the raw feedstock sources themselves or different formulated blends of those, there's also going to be mixture component segregation and preparation studies that'll take place. Looking at the process diagnostics for this task, a lot of what will take place is kind of benchmarking and assessing the active measurements during pre-processing and looking at feeding these back to achieve the types of quality specs that we need. So this slide shows one potential flow loop, for example, that's looking at real-time analysis of the particle size distribution after a mill and using that as an indicator for process production quality. And this slide shows a recent example from the Feedstock Conversion Interface Consortium that Ed had introduced. And this shows a really good example of what task 3, and I think the consortium is trying to achieve in general with the interconnectedness of these tasks. So previously we had looked at establishing relationships for pre-processing intensity and feedstock quality. In this example, looking at the air classification of forestry residues, which could be considered the tops and limbs after a lumber harvest, and applying air classification to separate some somewhat deleterious tissues for a catalytic fast pyrolysis process. So removal of needles, for example, significantly reduced the sulfur contamination within the feedstock, and removal of the bark reduced the amount of resin acids, some of the terpenes, and a lot of the waxes that could impact feeding and conversion, for example. And through the work that was done at Idaho, some of the analysis and conversion work that's done between NREL and the simulation work that's done between Oak Ridge and NETL, we were able to achieve some really deep understanding of how implementing pre-processing impacted the minimal fuel selling price. As a result of these as a result of this pre-processing impacting the properties, as well as the trade-offs between removal of some of the inorganics and organic materials and potential utilization of those in different co-product streams. So with that, I'd like to pass the mic over to our next task, feedstock variability sensing and control with Jim Parks.
Thank you, Jordan. The feedstock variability sensing and control task is going to be demonstrating cost-effective combination of sensing technologies so that we can get detailed characterization of the feedstock as it's entering the gasifier. So we'll be leveraging a lot of the existing capability and knowledge you just heard about from Jordan and his team on the pre-processing side and other activities we've had previously funded by the fossil energy program. We're very excited to be engaging with you in industry and want to engage further with you related to your operation of the reactors and the controls for reactors, because one of the primary objectives here is to get as much information of the feedstock as possible prior to the entering the reactor, such that we can control gasification for optimal product and reliability of the gasifier. Related to that, we have already had some discussions about feedstock standards, and we want to continue those discussions with the community. We'll be applying various sensor technologies, and we'll be looking at the modalities and information that you can get from those technologies as we characterize the materials. And then ultimately, we'll be filling up an open public-facing database, and also performing analytic methods to analyze and correlate the data to critical feedstock attributes and parameters and properties. So one of the great things about a public-funded research program like this is that we can be fully transparent and have public-facing data and basically public-facing analysis routines, so that you can see along with us how well and how accurate these methods will work. And ultimately in this task, after we get the database filled and our methods honed in and working well, in the latter years of the program, we intend to demonstrate a system at the pilot scale. So our team is shown here, again, 4 national labs represented, and you'll note that a few of the people on the team also participate in other tasks, and that will be good for crosstalk and collaboration across the consortium. So this one slide here, I think, is a great summary of this task and our objectives. We will be applying multiple sensor technologies to the characterization of the feedstock as it's on a conveyor belt system. As you all know, there are pros and cons with the different technologies. We'll take existing state-of-the-art technologies, but we'll also be pursuing some advanced sensing technologies and letting them work together to get the most information about the feedstock. The data analysis and correlation of all that data will be a major emphasis of this task. And this is where we intend to fill a very large database and also apply unique correlation and analysis methodologies. Ultimately, we want the information coming out of that analysis to provide the feed-forward information to optimize gasifier control. And there are a number of target kind of properties and information that are listed here under that feed-forward information on the right of the screen here. We're interested in hearing from you on what you're interested in as well. But we anticipate that we'll be having a lot of chemical composition information on blends if you're looking at a blended feedstock, ash content, but also the physical properties, the energy, heating, and value, also things like the particle size and porosity, which have important are important parameters in terms of the conversion and the mass and heat transfer that goes on with the feedstock in the gasifier itself. So we're looking to extend that list and also learn from you what is most valuable to you in terms of the control strategy you would like to implement. On the bottom, you see that we'll also in this task have some cross-cutting activities, interacting with industry. Again, that database, but important to the database curation of the data in the database is really important as we form metadata entries into the database, and integration with control strategies and the ultimate pilot scale demonstration. As we've mentioned, we're building on capabilities and expertise and experience at the national labs that have previously been supported by fossil energy and other offices in the Department of Energy. Just a few of those highlighted here that are very relevant to this task. At the National Energy Technology Laboratory, they've been investigating laser-induced laser breakdown spectroscopy, which is a great technique to look at elemental composition, potential ash-forming compounds, and so forth. At the National Renewable Energy Laboratory, they've been investigating near-infrared spectroscopy as a tool for chemical composition characterization, and you'll hear a little bit more on that on my next slide. At Oak Ridge National Laboratory, we're well known for our neutron capabilities. And so we've been applying those techniques for very detailed characterization of feedstocks, including things like mass and heat transfer coefficients. And then at Idaho National Lab, as you just heard from Jordan, the Buff Enough facility has a wealth of different technologies for the pre-processing and sorting of materials, but also for characterization. And so one of them shown here is particle size distribution via some imaging technology. So to give you a little bit more flavor of some of the work previously done and work that we will build on, this is some platform type work performed by Zofia Tillman at the National Renewable Energy Laboratory on near-infrared spectroscopy applied to feedstocks. So as you can see here, the analysis from the near-infrared spectroscopy can lend to detailed characterization and quantification of things like moisture content of the feedstock, as well as things like the plastic content. And so we've already looked at a number of different feedstocks in a previous project funded by fossil energy. And so this is a great starting point for this task moving forward. I'll also note that a lot of the analysis techniques that were utilized for the spectroscopy analysis are open source type codes. So these are things that were by design we're wanting to build off of and also build from the standpoint of being able to share openly and publicly with the community. At all the national labs, we have some of the most advanced tools and techniques for material science. And at Oak Ridge National Laboratory, we're well known for our neutron facilities, the spallation neutron source, which is the brightest neutron source in the world, and the high flux isotope reactor, which is another neutron facility that's been utilized for decades and continues to provide great science tools for the community to use. And so if we need to go in depth in terms of analysis of the feedstock materials, we have that capability in the National Lab system. This slide just highlights a couple of the things we've been doing in the gasification area related to feedstock characterization during the gasification process. We've been applying small angle neutron scattering, or SANS, to get detailed porosity measurements from feedstocks as a function of the temperature of exposure during pyrolysis and gasification. And then we've been utilizing neutron imaging, which can detect the evolution of hydrogen out of feedstocks, because hydrogen has a very high cross-section absorption for with neutrons. So these are available as we need them. So lastly, as I mentioned, a major part of our effort will be creating an open source artificial intelligence ready database. We do know that with these online sensing techniques, we're going to generate a lot of data. We'll be using hyperspectral imaging systems and other sensors that have real-time capabilities. So we'll be able to build a lot of data. And we'll feed that into the database that we're building in this consortium. As mentioned already, we'll be utilizing the Energy Data Exchange platform, a very successful and robust system at the National Energy Technology Laboratory. And then we'll be also linking and feeding that database on the EDX system with the data in INL's Bioenergy feedstock library that's associated with their biomass feedstock national user facility. So this is how we're going to approach filling the database. Again, curation will be really important, and we'll have metadata to feed into this database. But importantly, once we get that database established, we'll be looking at a number of different algorithms and methods to analyze and correlate the data to the information we're after. And everything from our conventional principal component analysis up to ML and artificial intelligence type approaches. And then, as I mentioned, we're quite interested in learning from everybody what kind of industry interests there are for the feed-forward information for gasify control. We also will be looking to link our information to information that we value for digital twin optimization. And that's something that you'll hear about more in terms of the modeling support from this consortium by Mehrdad, who will be speaking next on our Task 5 activities related to kinetics. So I'll hand it over to Mehrdad.
Thank you, Jim. Yes, the goal of this task is to develop a repository of validated kinetic models with product distribution for all the feedstocks that we test in this consortium. This repository will also have machine learning tools and capabilities to generate kinetic data and product distribution, even for feedstock that we don't necessarily have any data in the database available. So to achieve that, we will develop an interactive platform. We call it Kinetics Hub, where all the data that will be generated as part of this effort, and all the machine learning tools for various feedstocks, biomass, waste plastic, coal, and all relevant information for each feedstock will be housed there. Next slide, please. This is the activity across the labs, different labs for this task. NETL will develop both intrinsic and apparent kinetic models with product distribution, of course, for blended feedstock and also each component in the blend under pyrolysis and gasification conditions. We validate this for use in CFD, and then, of course, it'll be included in the database that I was just referring to. Oak Ridge will be conducting experiments to characterize changes in feedstock morphology that happens during thermal conversion. NREL will develop and validate a particle scale model to capture the heat and mass transfer effects that typically occur when we are dealing with large particles or pellets. And of course, INL will be providing the feedstock. And all of this should come together so we can model large pellet or large particle for co-gasification. Next slide, please. This is the NETL project team, 10 folks strong, will be responsible for the activities that I'll be describing shortly. Next slide, please. We've conducted ongoing, I should say, literature search that we're looking at what's available for the various feedstock in literature. And as you can see here, as an example, we're looking at polyethylene and polypropylene. There's a wide range in the activation energy of these two material. And this is primarily due to the feedstock properties, ultimate analysis, proximate analysis, composition, size, even the test procedure. It will affect the outcome. So that's important. That's very important for modelers because although there is a wealth of information out in literature, it's not usually that straightforward to be able to use that for the feedstock that you want to look at. Next slide, please. To remedy that, to develop a more predictive modeling tool, what we'll be doing is we'll be looking at intrinsic reaction kinetics using high pressure TGA experiments with small particles. And for the plastics, the 4 plastics that I'm showing here, we'll be looking at powder plastics. And for biomass and coal, we'll be looking at preferably particle size of 100 micron or less. We'll be carrying out the experiment, the TGA experiment, for a number of multiple heating rates and up to 20 bars of pressure. And what I'm showing here is some preliminary work that my colleagues have done. We're looking at the gas yield at 3 different temperatures for polypropylene, and also the composition of the tar and the heavier hydrocarbon that's being generated anywhere here from C14 to C36. Effort is now underway to characterize this tar composition more in terms of variable that can be used in modeling, such as mole fraction or mass fraction, for instance. Next slide, please. And here, since a gasifier typically operates at very elevated temperature, thermocracking of tar and heavy hydrocarbons must be accounted for. We have a 2-pronged approach to deal with that. One is, of course, experimentally develop kinetic models for tar cracking and heavier hydrocarbons, decomposition. The second approach is more analytical. We are looking at Gibbs-free energy minimization techniques to develop equilibrium-based kinetic models for tar cracking. And what you see here on the right-hand side is a preliminary plot of the mole fraction right now, up to 20 bars for tar or heavy hydrocarbon that was produced as a result of decomposition or pyrolysis of polypropylene. Next slide, please. Here is the database that we will be developing, the kinetics hub. This is actually a mock-up of it, and this is going to be a searchable database for kinetic and all kinds of relevant information that we may have. Of course, the look is it could change, but here one can go select type of feedstock, or if you're looking at pyrolysis, gasification, looking at certain composition, and then it should provide the available data that we have in the database. We'll be using, we're planning on using a knowledge graph, and this is a simple proof of concept of what this knowledge graph can look like and can provide. Here we are looking at methane, simple reaction, methane steam reforming. You will have, what we will have here is all the reactants and products. There'll be a place where it can point you to where the TGA data, for instance, resides. It would be a place for where the rate expressions are. And by basically clicking on each one of them, it can open up another window for you, another knowledge graph, basically point you in the further information for that particular material. And this, of course, is a potentially a nice way to organize and visualize very complicated kinetics. Next slide, please. And we will also be developing machine learning tools. For one thing, the goal here is to based on certain critical material attributes that comes from Jordan and his team, we will be able to search the database and figure out, or estimate rather, what the product distribution and rates need to be for a particular feedstock that we may not necessarily have in the database. We are also developing surrogate modeling tools that allows us to develop or be able to use very large mechanistic reaction models of the order of perhaps tens, if not hundreds of reactions and species. These type of reactions are not necessarily computationally cheap to run in CFD, but the goal here is to develop a ML-based model that can achieve the same thing reasonably fast. And the graph that you see on a right corner is some comparison that we're right now doing. This is for a polyethylene 10 reaction polyethylene model. And actually at various heating rates, we can see that the ML model is doing a good job. This is the conversion curve. We will also be developing, this is something we're exploring right now, an ML tool that will help the user develop an apparent kinetic rates based on TGA data. Here, all the user has to do is do the TGA. You have your mass loss and product distribution, and then the goal is to, instead of doing further analysis, to develop the rate expressions that we can achieve that through ML methodologies. This is actually kind of a brand new area. There are some literature out there on this approach with good success, and we'll be exploring it also to make it as part of the offering of this consortium. Next slide, please. This would be the work that will be done by by INL, and the project team, Jordan and Sahar are shown here. Aside from providing feedstock, The goal is to get information on critical feedstock attribute, such as what I've listed here, anywhere from size distribution, density, porosity, approximate ultimate analysis, composition, all of that good stuff that essentially distinguishes each feedstock from each other. And we'll be using this type of information in the database when I was talking about coming up with an ML-based approach that can help us based on these critical feedstock attributes to figure out what the reaction rates and product distribution needs to be for a material, for a feedstock that is not already in the database. The team from ORNL will be helping to develop or actually use the micro TGA that they have and leverage that to characterize solid residue product distribution, changes in size and density that occurs during the pyrolysis and gasification. And you can see an image of some of the work that they've been doing already with neutron radiology. Next slide, please. The team from INL, I'm sorry, from NREL here, they will be working on developing a particle scale model. You can see two simulations here, one for pine pellet, one for LDPE pellet at 770 C. These simulations will be used to develop the particle model that accounts for heat and mass transfer that occurs in large pellets and particles. And this model, of course, will be validated. Here we can see that how the LDPE pellet, for instance, it shrinks as it is pyrolyzing. And of course, the pine pellet becomes more porous. Next slide, please. There'll be another team from NREL that will be helping with the validation of experimental validation of the single particle model. Next slide, please. They'll be using the single particle reactor on the right hand, on the left hand side, I'm sorry. Here we can load up to 2 grams of pellets or particles, 3/4 of an inch in length and diameter, and this unit will be used to validate the single particle model. And of course, they also have a fluidized bed gasifier that we will be using to validate on the right hand side. Yes. Some of the other carry out experiment with different size pellets, and of course all of this information would be available and will be used for validation purposes. And I believe this should be my last slide, Nate. Yes, that's my last slide. Thank you.
All right. From there, I believe kind of wrap it up with looking at kind of the interaction of all of these tasks together under the NLGC. Again, I'm not going to go into a lot of detail here, but we've already had highlighted a lot of the interactions between the tasks here. Nothing's siloed at all, but the gasification is a pretty complex process, including everything that's happening upstream, a lot of trade-offs to consider, etc. So again, I won't go through everything, but we already had a good example of, say between the analysis task and the upstream feedstock task, task 2 and 3, some of the interactions that might need to occur. Task 3 needs to know, what are my feedstocks, costs, contaminants, etc., that are included there. Likewise, the task 3 provides feedback to the task 2 and the analysis on what are the pre-processing costs, some of the limitations and contaminants, removals, values of co-products, etc. So again, I won't go through everything, but there's a lot of interactions between the tasks. One thing that may be central is that you can see contaminants kind of listed here in the center, and that touches on all 4 of the technical tasks relative to, identification of contaminants, whether or not we remove those in a pre-processing step or a downstream syngas cleanup step. Is it more economic to do one or the other? How, if that stays with the feedstock, how does that contaminant react in the kinetic sense with other things within the gasifier, etc. So Again, something we'll be picking up in particular next year on the contaminant side, but a lot of interaction between all of the tasks, and again, a very holistic and concerted effort amongst all the tasks to work together to solve these challenges together. So with that, I'm going to kind of bring us home a little bit here with just to summarize what the NLGC is trying to do here. Again, our primary goal is enabling economic utilization of a bigger spectrum of alternative feedstocks, and then blending of those alternative feedstocks with more traditional feedstocks, biomass and coal, et cetera, to ensure fuel resiliency for gasification systems. And ultimately, if we can bring about change in which we can make blending or use of alternative feedstocks easier, that will provide additional economic benefits to the gasifier operators. So again, we would like to do that with information, tools to the industry, to you, on a number of different areas. I'd like to assess that economic gasifier siting is a function of that feedstock availability and markets that may be around, waste stream disposition, a lot of other things that, again, as Mike had mentioned, are part of that systems analysis task. Again, we'd like to assess the technical economic trade-offs on the feedstock pre-processing relevant to contaminants and feedstock formats, et cetera. How do those affect gasifier selection? How do those affect syngas cleanup needs? A lot to consider there as well. And we want to deploy some cost-effective sensing methods for real-time sensing of feedstock variability as they go into the gasifier to affect operational control of gasification systems. And finally, looking at the estimation of reaction kinetics, including product distributions for feedstocks under a variety of gasification conditions, so that we can enable some accurate gasifier design, and then again also affect improved operability potentially in real time. So with that, again, anything we do here, we would like to do with stakeholder involvement, which is part of the reason for the webinar here. So again, want to make sure we are performing impactful, relevant R&D to benefit you, the end user of our work here in the gasification space. So with that, I'm going to turn it over to Jim, who's going to kind of wrap things up and talk some about the industry survey that we would love for you to fill out for us.
Thank you, Nate, and thank you, everybody, for your participation today. I appreciate everybody joining in to hear about this consortium. We're very excited to be a part of this and very excited to be engaging with you over the course of this consortium. In terms of industry engagement, there was already a question, I think, in the chat about that. We have numerous ways that we intend to engage with you. One of them will be through webinars like this, and we'll also be active at conferences and public meetings and review meetings for the program. But also, we would like to have one-on-one discussions with industry. And also, to launch our engagement, we're conducting an industry survey. So we appreciate your input in the Menti type poll that we took earlier in this webinar. Our survey will be in a SmartShape format. The link is actually in the chat, and also the QR code on the screen will have a link to that survey. We will also provide a link to this survey in email, follow-up emails, and on the website that USEA has for this program. So there'll be multiple ways for you to fill out this survey. The survey will have similar questions to what we saw in the Menti poll in terms of like high-level interest from your organization and characterization or demographics of your organization that will help us analyze the more detailed questions that we have in the survey. We have about 23 questions in the survey. We're thinking this will take 10 to 15 minutes to complete. Some of the questions do get a little bit more detailed and pointed towards some of the questions that our tasks that you saw are interested in hearing about. So we would like for you to fill out that survey. We're planning to collect responses up to September 5th. If you have some time today to take it, that would be great. In addition to the questions that we have here, We will also have a question at the end, which will allow you to select opportunities to talk with us one-on-one with specific tasks or just overall for the consortium if you're interested in additional discussions. This survey, by the way, we'd like to hear what organization you're representing if you're filling out, but if you would prefer to fill it out in an anonymous format, that's fine. We are asking for your organization, your company name and contact, but if you want to participate in the survey and don't want to provide that, that is fine too. So appreciate your time and energy and look forward to hearing from you in this survey.
All right, thank you, Jim. I think with that, we will begin to wrap it up. I don't know, we have a very brief amount of time for some questions potentially. I know that some of that has been, some of those have been added to the chat. Ed, was there anything in particular that we could address briefly before we need to close today?
I see 7 questions in the chat. Some of them are technical. One is programmatic, and then some of the earlier ones on how can companies participate. And I think filling out the survey and making those connections is a good place to start. And I think that trying to answer any individual question right now, we would run over. So
Okay.
I know we've only got about 90 seconds. I don't think we're going to be able to fit anything in there, but we have them, we have the input, and we will try to get back.
Right. There is an opportunity also to ask questions at the end of the industry survey as well. So again, looking forward to interacting with everyone here. Please do fill out the survey. And again, if you'd like follow-up conversations, please put your email address in and we can follow up with you there as well. So with that, appreciate everyone's time and interest in the NLGC. I thank you to our excellent panel speakers here. So everyone, I think, did a fabulous job. Thanks again to USEA for hosting, for the website content, and in particular, thanks to Department of Energy, Office of Fossil Energy, the Gasification Program for funding and sponsoring this work going forward. So thanks again for everyone for attending, and please do fill out the survey, and otherwise have yourselves a great day. We will be in touch. Thanks everyone. Take care.
Thank you.